is that they don't get confused by simple indentation. They just see the blocks, they see what they want to do. So while it's unusual, and it might not be necessary to write secure code in Python, you might not need this feature, it actually makes a lot of sense. Even though from an adoption viewpoint, it might have been a bad idea because many people get scared because it's new syntax. Then the sufficient Hamming distance. This kind of bug is common. Something like this has been tried to be introduced into the Linux kernel too, I think. I don't remember the exact bug, but you just lose one equal sign and suddenly you have an entirely different meaning to the code. Then there's another problem where you just lose one comma in C, and suddenly you have automatic string concatenation because string concatenation is implicit. So you would want an explicit string concatenation operator like the dot in Perl there. So there's something good to say about Perl there. I don't know if it also has automatic string concatenation. Then there are some defense techniques. So much of the work I've been recently doing on all this, how to write secure code stuff, is just looking at what am I doing as a penetration tester? Where am I looking for bugs? And then thinking about techniques of reformulating the problem so those kind of bugs are harder to make for programmers. So one of those defense techniques is path normalization, where instead of just concatenating any random way, you first well, in this case, you don't do input validation. You just take whatever you get, you do whatever you want with it, but afterwards, in the end, you normalize it. You put it into a format that allows input validation after the fact. This just works for strings. I have a more, but slightly more complicated type-paste solution, which would also work here, but why bother? This works. So normalizing means you remove all the dot, slash, and I mean normalized and absolute. So you replace all the local paths with global paths. And in the end, then you only check, does it start with the jail directory? Does this path lead outside of the directory where I actually wanted to read the file from? So any kind of dot, slash to read etc passvd is not going to work anymore with this. Good, then there's another example. I haven't finished my slides for this, but basically the idea is if you get user input from any user source from a keyboard and transmit it over a wire, it's text. It's also a string, but it's text. And text has the, well, and if you have some template, HTML template, then you have a string also, but it's an HTML string. So there's a different type. You have HTML in there. It's readable as HTML, not as text. If you try to read it as text, you have lots of weird characters that don't make sense in text. So, and the other way around, you might have weird characters in text, and they make very weird and bad for security interpretations in HTML. So by making it explicit that there are different types of strings allows for enforcing conversion, because the problem we have there is this is not about introducing something that is really annoying because you have to do it all the time. This is about, right now we are teaching in those of us who are teaching courses in writing secure code or how to fix web applications and so on. We are teaching day by day, well, if you use user input for an SQL query, just escape it. If you use user input in an HTML page, escape it every single time. So you need to escape every single time. So how do I get my framework, my programming language, my programming environment to force me to escape every single time? In this case, I can use the type system. Also you can do the same thing in Python. You can emulate it in various ways. You just enforce that strings get converted to however they are used. So, I think this is the end already. Yep, it is the end. So I'm just going to summarize. You need to know what you want to do and what you don't want to do if you want to write secure code. Good tools seriously improve code quality, even with bad programmers. Good programmers are definitely a lot better than bad programmers, obvious. Coding standards set a baseline for code quality. So the future work that I'm planning on this is if you have code standards, maybe you can bring part of them into some kind of abstract format and actually use this to verify that certain things that make sense are actually done. So I'm not talking about full static analysis to find bugs, but I'm talking about changing the way things are implemented for doing, like, changing the way you program so it's easier to analyze, easier to verify, and easier to not make a bug. And yeah, this is the next big thing. How can we put this whole thing, this whole software development process into a real framework, into a methodology, and add the necessary verification steps that they become effective and not just any, not just anyone can go to companies and claim he helps them make more secure code, because then they are not going to make more secure code. But the same thing applies. If you make this methodology, I'm sure some of the open source projects can also benefit from this. Some of them are using extreme programming techniques and so on. So there's a lot of room there, and I would like to discuss afterwards on how we can proceed from there. So that's been the talk. Other questions?
Which coding standards do you recommend? Which coding standards do you recommend?
Well, very much agreeing on certain ways. For example, we are dealing with a complex environment there, so we need to we cannot just say very high level we do it like this, because this is not going to work. When we do penetration tests, we know where to expect bugs, so we have to fix it there, where people have just psychologically make those kind of bugs. So, for example, using a simple coding standard would be to say, we use prepare statements for all our SQL queries, because then if we do that and we only use constant strings for the template, then there won't be an SQL injection problem, because prepare statement fixes the problem. We could also use something like this type system approach. Just make this a coding standard and then look for uses of, well, verify when you do a check-in to the source code repository, is some other way to make a database access done, for example. Or check for, well, basically doing tainting checks to some regard, but also doing basically verifying that these things you agree on. Basically, I don't have any fixed set of methodology right now. I've been working with a few companies recently. After doing a penetration test, I made a workshop with the team, and we've been looking at the kind of problems they had in their source code and then discussing these exact things. Oh, this is a problem, you made a typo there, or oh, this is a different type, so maybe we should abstract this further, or there's much too much code. This decision function is 8,000 lines long, so that's not a good thing. We need to make it shorter, and there's a pattern that helps with that. So if we use a dispatcher and not if, it gets better. So I would like to have some, to develop a standard set of how to develop secure code, independent of the programming language, focused on the problems we are having. But this is going to take some more time.
You mentioned ASN1, and I remember well when this was on the security bulletins. How come that this applied on several platforms and so many services at the same time when this is, as you said, an implementation problem? I thought that implementation would be pretty different on different OS platforms.
Me too. So, well, obviously, they copied from each other, definitely. But also, there are re-implementations. So,
But regarding their license policies, they shouldn't be able to copy.
I'm not a lawyer, so I wouldn't know. It's just there. It's just evidence. I'm trying to interpret it.
Okay, thank you.
Thank you.
I like your idea of the type system for tracking data validation. Are you aware of any implementations in real life applications of that kind of stuff?
I know of maybe 4 implementations. So there are 2 Java implementations which we worked on at, well, 2 of my customers. And I know of 1 implementation that I made in Python and 1 implementation that Andreas Bock made in Dylan. So both of these are just experiments to get a feel for what's possible there.
Okay, thanks.
Thank you.